Hi students, good morning, good afternoon, good evening to everyone. Please welcome to the physics wala. Okay, yes, before going to start the first chapter in this batch, first of all I will welcome you to the UMEED NEET English batch in pure English for all NEET 2025 aspirants. Okay, and in today's lecture we are going to discuss a very important chapter, that is units, dimensions and measurements. Okay, before going to see what are the topics we have to cover and what are the topics we have to understand from this particular chapter, let us have a brief idea about the weightage of this particular chapter. So whenever we observe the past 2 to 3 years or 3 to 4 years, we can say that from this particular chapter we can expect the 3 questions, minimum of 3 questions from this particular chapter, units and dimensions, or units and measurements, we can say. But previously that is before 2020, we can say that we can expect only 1 question from this particular chapter. But after that from the past 3 to 4 years, as I said, we can expect minimum of 3 questions from this particular chapter. So why we have to keep more concentration in this particular chapter, and we have to learn each and every topic from this particular chapter, so that we should not miss any of the questions in the NEET entrance examinations. Okay, so see that in this lecture we are going to discuss about the units and the system of units. Later we can go with the dimensions and analysis, dimensional analysis. Later we can go with significant figures, and briefly we will discuss about errors and the combination of errors. As you know, this batch will be in pure English, and also it is a one shot lecture. So why I am requesting everyone to concentrate and make down each and every point, make a note of each and every point. And in this video or in this lecture, I am going to discuss briefly about the synopsis of this particular chapter, and we will solve the few models or the MCQs which can be asked in the NEET entrance examination, so that you will get an idea how to answer the questions from this chapter, and also how to analyze the questions, and also based on this we can practice as many questions as possible by taking any of the reference materials. Okay, I hope you will concentrate and you will learn and you will enjoy the session. We will start our class. So first of all, before going to see the units, first of all let us understand briefly about the idea of physical quantity. So what is a physical quantity? Especially see here in science, we deal with the many physical quantities. So first of all we have to understand the meaning of the physical quantity. So please make sure about this. Anything which can be measured, and expressed mathematically in the form of Q is equals to N into U, is called a physical quantity. See here, in our real life situation, we may come across many quantities that can be measured and that cannot be measured. There are certain quantities which cannot be measured, and such quantities cannot be expressed in mathematically also. So by such quantities cannot be called as physical quantities. So see here, so what are those quantities that cannot be measured and expressed mathematically in the form of Q is equals to N into U? For example, we can say our happiness, sorrow, sad, love, like, dislike, height. These are all the quantities which cannot be measured and which cannot be expressed in the form of Q equal to N into U. So why these quantities cannot be discussed in our physics, or especially in science. Is it clear? So what is this Q? What is Q stands for? Observe this, where Q stands for the quantity. Q stands for the quantity, and N stands for the number. N stands for the number, and U represents a standard physical quantity. We can call it as a unit. For example, suppose see here, whenever the quantity remains constant, we can say that N1 into U1 can be written as N2 into U2. For example, we can say that whenever we take a mass of basket of apples, we can express this as 5 kg. Otherwise, we can also write this as 5,000 kilograms. Is it right or not? So just observe this. Whenever the quantity, that is mass, remains constant, we can write in two different ways. One is 5 into kg, and otherwise 5,000 grams. And from this, we should also understand that when quantity remains constant, then the number is inversely proportional to its unit. If the number is more, the unit will be less, and if the number is less, unit will be large. So observe this, the number is high, 5, and kg is the larger unit compared to this gram. Is it right or not? You are all familiar with these things. So like that, we have to understand the meaning of this physical quantity. Later, what are the different types of physical quantities? So first of all, we have to understand about the fundamental quantities. So please make sure you are understanding each and every point. So how can we define the fundamental quantities here? The quantities which are independent. The quantities which are independent, are called fundamental quantities. What are the example for these fundamental quantities? We can say here, best examples are mass, length and time. Mass, length and time are the best examples of fundamental quantity. That means these quantities do not depend on any other quantities. Okay, they exist by own. And such quantities are called as fundamental quantities. And second one, we can go with derived quantities. You are all familiar with these points because you have learned these quantities from in school level only. Is it clear? So what are the derived quantities? How can you define these derived quantities? The quantities which depend on the other quantities, that is especially fundamental quantities. Okay, are called derived quantities. For example, whenever we go with the density, density is nothing but mass by volume, or we can say that mass divided by volume can be length into breadth into height. That means it depends on the fundamental quantity mass and also fundamental quantity length, we can say. Is it clear? And similarly, whenever we go with the second example, that is force. Force is nothing but mass into acceleration. So mass into acceleration can be written as velocity divided by time. Otherwise, we can write velocity can also be written as distance divided by time. Therefore, we can say that Force is a physical quantity. Force physical quantity which depends on the fundamental quantities like mass, length and time. Mass, length and time. Okay. So like that we can define or we can classify the physical quantities into two types. One is fundamental and the other one is derived physical quantities. I hope you are understanding these points. Now let us move on to the what is the unit? What is the unit? How can you define this unit? How can you define this unit? So please observe this. What is a unit? Unit is nothing but a physical quantity, especially we can say standard physical quantity which is used to compare or which is used to measure other physical quantities. So please observe this. Unit is nothing but a standard. It is nothing but a standard physical quantity used to measure or the compare the other physical quantities. Okay, is called a unit. For example, we can say kilograms, grams, meters, centimeters, seconds. These are all the units. We can call these are all the units. So see here, how can you define or how can we classify the units? Types of units. So based on the quantities we are having, just now we have studied that we are having the fundamental quantities and derived quantities. So similarly we can also move on to types of units. The first one is fundamental units. What are these fundamental units? How can you define these fundamental units? So see here, the units which are used to okay measure the fundamental quantities okay are called what is it? Fundamental units. Example for the fundamental units, best example we can say kilogram. I will write it kilogram, comma, meter and second. These are the best examples of the fundamental quantities. And later whenever we want the second one, that is derived units. We can define the derived units in two ways. One way, the units which are used to measure the derived quantities, or second way, the units which are which are derived from the fundamental units are represented as a derived units. So see here, in simple words we can say that the units which are used to measure the derived quantities are called derived units. I hope you are understanding these points. What example for the derived units we can say here? So please think about this. Meter per second. Meter per second is a unit which is used to measure the derived quantity, speed or velocity. Later we can go with kg per meter cube. Otherwise we can say that kg meter per second. So like that we can give the n number of derived units. See, a meter per second is a unit used to measure the derived quantity, the speed. Kg per meter cube is a unit which is used to measure the derived quantity, density. And also kg meter per second is a unit used to measure derived quantity, momentum. So like that we can give the n number of examples for the fundamental units and derived units. Now we have to think the another point. What is that mean? See here, whenever we group these units, these fundamental units together, whenever we put these fundamental units together, okay, then we will get a system, and that system is referred as system of units, system of units. So please understand that what are the system of units, system of units. So what is the meaning of system of units here? I said to you that whenever we group all the fundamental units, then that group is referred as a system of units, system of units. So please observe this, the group of, I will write here, the group of fundamental units, the group of fundamental units, the fundamental or the group of units, simply we can say that the group of units, is called system of units, is called system of units. There are different types of system of units, system of units. What are they? So please have a look about here. First one we can go with the FPS system. What is F here? F stands for foot, and P stands for pound, and S stands for second. S stands for second. FPS system. And second we can say CGS system. System, that is centimeter, comma gram, comma second, okay. And third one we can say it is MKS system. M stands for meter, okay. K stands for kilogram, S stands for second. So these are the three major system of units we have studied in the lower sessions. See here, in all these system of units, length is measured. See, in FPS system, especially FPS system, length is measured in foot, mass is measured in pound, and time is measured in second. In CGS system, length is measured in centimeter, mass is measured in gram, and time is measured in second. And in MKS system, we can say length is measured in meter, and mass is measured in kilogram. We can say time is measured in second. Okay, these are the different types of system of units. But one thing it should be understand, we have to observe. What we have to observe? Please concentrate on this system of units. In all these three system of units, we can observe only three quantities. What are they? Length, mass, and time are taken as the fundamental quantities. This is the first point we have to keep in our mind. And second point, whenever we come across second point, see, observe this. In all the three system of units, the unit which is constant, which remains constant, that is second, and that is for time. Is it clear? In all the three systems, the second is a common unit used to measure the quantity time. Okay, these are the two important points you have to observe from these three system of units. Later, as the time passes, especially in the 19th century, people came to know that other than these three fundamental quantities, units are the quantities, okay, we have to consider the few more quantities under the fundamental classification. Okay, by including those fundamental, we can say, or we can have one more system of units. We can refer it as a SI system. So please observe this. In SI system, there are 7 fundamental quantities. In SI system, there are 7 fundamental quantities, which represents the 7 fundamental units, and 2 supplementary quantities. two supplementary quantities. Okay, what are they? What are they? Let us have a look about the 7 fundamental quantities. Okay, and how to represent the units of those 7 fundamental quantities. So see here, the SI system consists of the 7 fundamental quantities. What are they? That is mass, you can say mass, length, time, you can say temperature, electric current, and we can say luminous intensity, and finally we can go with what is that amount of substance. So what are the units? So please observe this. Mass is measured in kilogram. And the symbol is kg. Length is measured in meter. Symbol is m. Time is measured in second. Symbol is s. Temperature is measured in Kelvin. Capital letter K. Electric current is measured in ampere, denoted by symbol capital A. Luminous intensity is measured in the candela, denoted by symbol CD. An amount of substance is measured by the unit mole. We can say MOL. Is it clear? I hope you understood these points here. These are the 7 fundamental quantities, which are included in SI system. Okay. What are the supplementary quantities we can say here? Supplementary quantities. So please have a look about this supplementary quantities. First one, that is plane angle measured by the unit radian and denoted by the symbol RAD. And second one is solid angle measured by the unit steradian, and it is denoted by symbol SR. So these are the 2 supplementary quantities. So how can we understand, or how can we define these 2 supplementary quantities? See here, the definition of these fundamental quantities will never be asked, but the definitions of these supplementary quantities are asked in the previous papers. So why we should require the knowledge of the definition of this plane angle and solid angle. Okay, so observe this. How can you define this plane angle? So see here, what is the definition of this plane angle? Usually denoted by theta. So please observe this. Whenever we consider, or we can say that, defined as the ratio of arc length to radius, is called as a plane angle. So I will show it through the diagram. So observe this. There is an arc AB. Let C be the center of the arc. And whenever you observe this arc is making an angle theta at the C. Okay, so see here, if we represent L as the arc length, and AC or BC as the radius. See here, L is the arc length, and R is the radius of the arc, and theta represents the plane angle. Then The plane angle is defined as the ratio of arc length divided by radius or theta is equals to L divided by R. I think you are all familiar with this formula. Theta is equals to L by R. Otherwise we can say L is equals to R theta. Is it clear? So please observe this. What is the unit? What is the unit of this plane angle? As we discussed, it is measured in the unit of radian. So how can we define 1 radian here? How can we define 1 radian? 1 radian. So please observe this definition of radian. If before this we know that theta is equals to L by R. Suppose if length of the arc is equals to the radius of the arc, length of the arc is equals to radius of the arc, then we can write theta can be written as L divided by L. It becomes 1 radian. So how can I define this radian? Radian is defined as the angle subtended by the arc, whose length is equal to its radius, Okay, this is how we can define 1 radian. Okay, if you want, I can write the definition here. So please note down these points clearly. The angle subtended by an arc of length equal to its radius. Okay, is called 1 radian. Okay, I hope you are understanding these definitions about the plane angle or the radian Okay, plane angle is a quantity, radian is a unit, and please remember SI unit of the plane angle is always radian. Okay, there are other angles which are used to measure the angle, that is degrees. Okay, degree is also another unit used to measure the plane angle. Okay, later we have to understand about the solid angle. So please observe this. Solid angle denoted by d omega. So please look at the board and make a note of these points. So how can we define this? It is defined as the ratio. It is defined the ratio of area of the surface to the square of the radius. Square of the radius of the surface. Okay, I will explain to you. No need to worry about that. Please observe. A spherical surface. And let us imagine a small part of that surface. Which subtends an angle. At the point O. Let R be the radius. And let us consider dA is the area of the surface. What is dA? dA stands for area of the surface. Then the solid angle is defined as the ratio of area of the surface to the square of the radius. Measured in the unit steradian. And remember that plane angle is a 2-dimensional quantity and solid angle is a 3-dimensional quantity. Okay, please make a difference. So how can we define this steradian? How can I define one steradian? One steradian. So please, similar to the radian, definition of radian, we can understand the definition of a steradian. So please observe this. We know that the solid angle is written as dA divided by r square. Suppose, please observe this. If the area of the surface, the area, that is the magnitude of the area, remember my words, magnitude of this area, area is equal to the square of the radius, then we can say that d omega is equals to dA divided by r square. We can say it is equals to 1 steradian. Like this we have to define. So I'm going to give the definition of the steradian. See, observe this. Steradian is defined as, that is one steradian is defined as, the angle, subtended by a surface, whose area is equal to, the square of its radius, This is how we can give the definition of the steradian. Okay. So these are all the points. What we have to learn and what we have to practice. In the concept of units. Okay. Later we have to move on to the next concept. That is dimensions. What are these? Dimensions of a physical quantity. Okay, before going to give the definition of the dimension, let us have an example. For example, if you want to write the density, density is defined as mass divided by volume. Is it clear? Mass divided by volume can be written length into breadth into height. Therefore, m divided by, what is length? Length is nothing but a fundamental quantity, L only. Breadth is also length only. Height is also length only. Therefore, we can say m divided by L cube. Or we can say m to the power of 1 and L to the power of minus 3. That means, please look at the board and listen to my words carefully. If I want to represent the quantity density, I want to raise the fundamental quantity mass and length to the power 1 and to the power minus 3 respectively. Is it clear? I am repeating that. If I want to represent the quantity density, I want to take the mass to the power 1, length to the power minus 3. Is it clear? Similarly, let us observe the second example. Whenever we want to represent what is the quantity pressure, pressure is nothing but force by area. Force, how can we define this unit of force here? kg meter per second, kg meter per second square. Area is meter square. That means we can say that, what is kg? Kg is nothing but mass to the power of 1. Meter is unit of length. So why we can say that liter, that is length to the power of minus 1, and time, that is second to the power of time. For example, I will write t only, that is the time to the power of minus 2. Is it clear? Therefore, what can you say, or what can you observe this? To represent any physical quantity, we have to use the fundamental quantities to certain power. For example, in density, mass is mass is to be raised to the power of 1, length is raised to the power of -3, and to represent force, I want the three fundamental quantities: mass, length and time. Mass, length and time. Is it clear? So we can say that mass to the power of 1, length to the power of -1, time to the power of -2. Is it clear? Therefore, how can we define the dimensions? How can we define the dimension? Now please observe this. How can we represent the dimensions? Dimensions are nothing but the powers. Dimensions are nothing but the powers to which the fundamental quantities, the fundamental quantities to be raised to represent a physical quantity, This is how we can define the dimension. Dimensions. I hope you understand. Is it clear or not? Please analyze clearly. Analyze these points clearly. Okay. So dimensions are nothing but the powers to which the fundamental quantities are taken, are raised to represent a physical quantity. And see here, what is the dimensional formula? Please have a look about this. What is the dimensional formula? So please, dimensional formula is nothing but the expression. It is nothing but the expression which represents how and which fundamental quantities, are used to represent or to have a physical quantity, any other physical quantity. ಅರ್ಥ ಆಗ್ತಾ ಇದೆ ಅಲ್ವಾ ಏನು ಹೇಳ್ತಾ ಇದೀವಿ ನಾವು ಅಂತ ಅಂದ್ಬಿಟ್ಟು? So please make a note of these points. The expression which represents how and what fundamental quantities are used to represent a given physical quantity. For example, and see here, dimensional formula is always represented by an alphabet within a square bracket. For example, see here, if I want to write what is m, dimensional formula for mass, I can write or I can use a capital M within a square bracket. And similarly, length is represented by capital L within a square bracket, and time is represented by a T within the square bracket. And later, what is the electric current? Usually it is represented by the capital letter A, or in some materials it is also represented by capital letter I. So no worries. Electric current, capital A, and the temperature is usually represented by capital letter K within square brackets. And next one is the amount of substance is represented by MOL. There is no change. And similarly, whenever we go with the luminous intensity, but to the maximum extent we will not use that luminous intensity, that is a candela. So no need to worry about that. So see here, these are the dimensional formula for fundamental quantities. This is how we can represent dimensional formula. And one more thing we should keep in our mind. If you want to write the dimensional formula, of any physical quantity. Okay, first we should know what is the formula, related for that quantity. Otherwise at least we should know what is the unit, for that physical quantities. Then only it is possible to write the dimensional formula. Otherwise it is not possible. For example, so see here, for example, please observe this first one. If you want to know what is the dimensional formula for force is nothing but mass into acceleration. Mass can be represented by capital M to the power of 1, acceleration L to the power of 1, L to the T to the power of minus 2. So dimensional formula for the force is nothing but M power 1, L power 1 and T power minus 2. Similarly, second one, that is work, is for the work. How to write the work? We know what is the definition of that. We can say force into displacement, or we can write what is the SI unit of work. We can write kg meter square per second square. So from this I can write the dimensional formula for work as M power 1, L power 2 and T to the power of minus 2, T power minus 2. Okay. And similarly, third one, whenever we go with the pressure, already have explained to you what is the pressure, force by area. Unit is kg per meter per second square. Therefore, so see here, force divided by area. What is the unit? Unit is nothing but kg per meter per second square. So what is the dimensional formula here? M to the power of 1, L to the power of minus 1, T to the power of minus 2. That is the dimensional formula of the pressure, Similarly, whenever we go with the other quantity like magnetic induction or magnetic field, B. How to write the B? In order to write the dimensional formula for the B, at least we should know what is the relation. So see here, we can write, observe this, F divided by current I into L. This is a magnetic force. We have learnt in the chapter moving charges and magnetism. So based on this, I can write, observe this. What is the unit of this force here? Force can be written as kg meter per second square. Current is measured as ampere. Length is measured by the unit meter. Okay, therefore, by considering these units, I can write the dimensional formula as M power 1 kg mass, M power 1 meter. Here meter will get cancelled. So what is the dimension of the length? Dimension of the length will become equal to 0. And see here, T to the power of minus 2, A to the power of minus 1. This is how we can write the dimensional formula of the magnetic field. Is it clear? So like that, we have to think about the relations. And we have to learn the relations and the units to write the dimensional formula of any physical quantity. Okay. So for this, I have not given the list of dimensions of all the physical quantities, but I request you for dimensional formula of various physical quantities. Refer the best book, that is NCERT. But that too appendix anta ನಾವು ಹೇಳಿರ್ತೀವಿ, ಲಾಸ್ಟ್ ಅಲ್ಲಿ ನಿಮಗೆ ಇರುತ್ತೆ. ಈ ಅಪೆಂಡಿಕ್ಸ್ ನೀವು ನೋಡಿದಾಗ ನಿಮಗೆ ಅದರಲ್ಲಿ ಡಿಫರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟೀಸ್, ನೆಕ್ಸ್ಟ್ ಕ್ವಾಂಟಿಟಿಯಲ್ಲಿ ರಿಲೇಷನ್ ಫಾರ್ಮುಲಾಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಅದರ ನೆಕ್ಸ್ಟ್ ಕಾಲಮ್ ಅಲ್ಲಿ ನಿಮಗೆ ಯೂನಿಟ್ಸ್ ಬರೆದಿರ್ತಾರೆ. ಅದರ ನೆಕ್ಸ್ಟ್ ಕಾಲಮ್ ಅಲ್ಲಿ ಆ ಯೂನಿಟ್ಸ್ ಇಂದ ಡೈಮೆನ್ಷನ್ಸ್ ನ ಹೇಗೆ ಬರೀಬೇಕು ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಲಾಸ್ಟ್ ಕಾಲಮ್ ಅಲ್ಲಿ ಫೈನಲ್ ಡೈಮೆನ್ಷನಲ್ ಫಾರ್ಮುಲಾನ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಿದ್ದಾರೆ. ಓಕೆ, ಸೊ ಪ್ಲೀಸ್ ಡೂ ದಿಸ್ ಆಸ್ ಎ ಹೋಮ್ ವರ್ಕ್. Please take this and list the dimensional formula of various physical quantities by referring NCERT textbook. By referring the NCERT textbook. Okay, and in simple way, I have given a tabular column. Which represents a quantity, which represents a quantities which are having the same dimensional formula. Okay. Before going to see this, let us have an idea about the angle. How can you define the angle here? How can you write the dimensional formula of this angle? So see here, angle is nothing but length by radius. So length by L will get cancelled. It is equals to 1. Therefore 1, what is 1? 1 is a number. It is not a physical quantity. Therefore we can say number is said to be a dimensionless quantity. So from this we have to learn that any dimensionless quantity can be represented as m power 0, L power 0 and t power 0. For example, angle, and I will give one more example for this. That is strain. Another quantity, strain is defined as the change in length divided by original length. Therefore we can say length is having the change in length is having the dimension L, and length is also having the dimension L. So both will get cancelled, leaving 1. Therefore what is the dimensional formula for the strain? We can say m power 0, L power 0, t power 0. What is the meaning of this? The strain and the angle are the two quantities which are having 0 dimensions in mass, 0 dimensions in length, and 0 dimensions in time. 0 dimension is in time. Okay, so like that we have to understand about the dimensional formula and how to write the dimensional formula for various physical quantities. Okay, and here I have given a tabular column which plays a very important role. So which represents, or in this table there are quantities which are having the same dimensional formula. For example, please have a look here. For the quantity frequency, angular frequency, angular velocity, velocity gradient, and decay constant. These are all the quantities having the same dimensional formula, that is m power 0, L power 0, t power minus 1. m power 0, L power 0, t power minus 1. Okay, and later observe this, m power 1, L power 2, t power minus 2. This is the dimensional formula of all this quantity: work, internal energy, potential energy, kinetic energy, torque, moment of force. Similarly, observe this, m power 1, L power minus 1, t power minus 2. Pressure, stress, Young's modulus, bulk modulus, modulus of rigidity, energy density. So these are all the quantities which are having the same dimensional formula. So similarly for momentum and impulse, this is the dimensional formula, and for acceleration due to gravity and the gravitational field intensity, we can say dimensional formula is L power 1, t power minus 2, m power 0. And later we can go with the thrust, force, weight, energy gradient. These are all the quantities which are having the same dimension formula, m power 1, L power 1, t power minus 2. Okay, So similarly, we can go with that is the angular momentum and Planck's constant have the same dimensional formula m power 1 L power 2 T power minus 1, and surface tension, surface energy. Surface energy is nothing but energy per unit area. Have the same dimensional formula m power 1 L power 0 T power minus 2. And observe this dimensionless quantity, that is m power 0 L power 0 T power 0. Please observe these things, very very important. You can expect this question under NEET or KCET or any other state-wise entrance examination or national-wise entrance examination. So see here, strain, refractive index, relative density, angle, solid angle, distance gradient, relative permittivity, that is dielectric constant, relative permeability, etc. Okay, these are all the physical quantities which are dimensionless, therefore we can write m power 0, L power 0 and T power 0. Similarly, whenever we go with latent heat and the gravitational potential, we can say if these two quantities will have the same dimensions, that is m power 0, L power 2 and T power minus 2. If you want, you please check it. And if you have any other doubt related to this, please put a comment so that I will explain to you without fail. Okay, I hope you are understanding and you are following about this dimensional analysis, dimensions of the physical quantity, and how to write or how to analyze the dimensional formula for given quantity with the help of the relation or with the help of a unit, Okay, don't fail. Please work on this particular topic, because definitely there will be a question based on this concept. Okay, now let us move on to the what are the applications of dimensional analysis. Okay, before going to see the dimensional analysis applications, let us have one important principle. You can say it is a principle of homogeneity. Okay, so what is this principle of homogeneity states? Very very important principle. So see here, observe this. Principle of homogeneity states that in a physical relation, okay, all the quantities should possess or should have the same relation or same dimensions. That means whenever there is an equation, in the sense LHS equals to RHS, like that, whenever there is an equation, in that particular equation all the terms must possess the same dimension. That is the principle of homogeneity. Or we can also state this principle in another way. What is that? Observe this. The quantities which has the same dimensions, can be added. The quantity which has the same dimensions can be added or subtracted. The quantity which are having the same dimensions, only such quantities can be added or can be subtracted. Then what can you say about the quantity which are having different dimensions? They cannot be added or they cannot be subtracted, but they can be multiplied. Okay, so that is about the principle of homogeneity. Okay, we will see the applications while seeing or while learning the application, then you will come to know how to understand, how to apply this principle of homogeneity. Okay, please don't worry about that. Let us have the applications of dimensional analysis. First one we can say that to check the correctness, to check the correctness of the given equation, to check the correctness of the given equation. For example, say, observe this. If there is an equation, v is equals to u plus at, you are all familiar. Is it equations of motion, where v stands for final velocity, u stands for initial velocity, a stands for acceleration, and t stands for time. Is it clear? V equals to u plus at. This is the equation given to you. Is it clear? And we have to check whether this equation is correct or not. So how can we do it? Just apply the principle of homogeneity. See here, there are LHS and RHS. Whenever you take the LHS, there is only one term in the LHS, that is v. What is the dimensional formula of v here? L power 1 t power minus 1. L power 1 t power minus 1. Okay. And whenever we go with the RHS, there are two terms. One is u. L power 1 t power minus 1, and a into t. A acceleration, L power 1 t power minus 2, time t power 1. So whenever we do simplification, we can say L power 1 t power minus 1, we will get it. So observe this. By applying the dimensional analysis, by applying the principle of homogeneity, we came to know that, in a given equation, all the terms have the same dimensions, Therefore, we can say that the given equation is correct. Is it clear? So that is about to check the correctness of the given equation. And later, second application, observe this. To convert the unit of a given quantity, to convert the unit of given quantity from one system to another system, Okay, to convert the unit of given quantity from one system to another system, we can make use of this dimensional analysis. For example, see here. For example, I will say convert. I will give you the question, that is convert the density, the quantity density from SI system to CGS system. So how can we define? So see, what is the quantity given to you? Quantity is nothing but the density. See here, in this question, quantity is kept constant, but the system of units has been changed. That is, first system is SI and second system is CGS. And in the beginning, I have explained that whenever the quantity is constant, we can write N1 U1 is equals to N2 U2. So what is the dimensional formula for the density here? We can say M power 1, L power minus 3, T power 0. Is it clear? So please think about this. So let us say, I don't know, let us assume that N1 is equals to 1. Therefore, we can say 1 into first system is SI, no? Therefore, we can write U1. What is the U1 here? We can write kg. Otherwise, dimensional formula, first system M1 power 1, L1 power minus 3, n2 into m2 power 1 L2 power minus 3. I want to know what is the value of n2. Therefore, n2 can be written as m1 divided by m2 to the power of 1. Later, L1 divided by L2 to the power of minus 3. So, please think about this. How can you write m1? m1 is kilogram and m2 is gram. Is it to the power of 1? L1 is meter. Okay, L2 is centimeter to the power of minus 3. Therefore, we can write n2 becomes equals to, please look at the board here, 1000 gram divided by gram into power 1, 100 centimeter divided by centimeter to the power of minus 3. So, whenever we do simplification here, 10 to the power of 3 into 10 to the power of minus 6, you will get 10 to the power of minus 3. That is, value of n2 is equals to 10 power minus 3. Okay. Therefore, are you following? No? I hope you are understanding these points, how to convert the unit of one quantity from one system to another system. Okay, very, very important. So, see here, we can write n1 u1 is equals to n2 u2. So, what is n1? We can say 1 kg per meter cube is equals to, what is n2? n2 can be written as 10 to the power of minus 3, gram per centimeter cube, Okay. So, this is the how we can convert. We can convert the unit of density from SI system to CGS system. Okay. I hope you understood this point clearly. Okay. So, please go through it and listen to my words carefully. Then definitely you will get a clear picture about this application. Let us move on to the third application. What is the third one? To obtain the relation. Between various physical quantities. Okay, for example, so please observe this. Let us consider a particle which is moving in a circular path, okay, of radius r, moving with velocity v and having the mass m. So, please observe this. M is the mass of the particle. V is the speed of the particle. R is the radius. And one should know that whenever a particle is moving in a circular path, it must possess the centripetal force. Okay. And that centripetal force always acts towards the center. Therefore, F represents the centripetal force. So, what is the relation? For the centripetal force in terms of these quantities? How to get the relation? For the centripetal force in terms of mass, speed, and r. That is so see here, one thing we are saying that force is depending on mass, velocity, and radius. Therefore, we can say that F proportional to m to the power of x, v to the power of y, r to the power of z. By removing the proportionality, I can write equality with some constant, that is m to the power of x, v to the power of y, r to the power of z. Let us call this equation as equation 1. Okay. So, please observe this force. How can write the dimensions? Write the dimensions of these quantities. Observe this. M to the power of 1 L to the power of 1, T to the power of minus 1. That is the dimensions of this force, and it is equals to K. K is a dimensionless constant. K is a proportionality constant, therefore we cannot take the dimensions for that K. We can say that, let us take the K as 1 only. We can say M, mass is nothing but M to the power of 1 whole to the power of x, V, L power 1 T power minus 1 to the power of y, L to the power of 1 to the power z. So whenever we do simplification, so please observe this, M power 1, L power 1, T power minus 2 is equals to, observe this, M to the power of x, L to the power of y plus z, y plus z, and T to the power of minus y plus z, minus y plus z. Now applying the principle of homogeneity, that is, when the bases are same, the powers must be same, is it clear? Therefore we can say that x will become 1, y plus z is equals to 1, minus y plus z is equals to minus 2, is it clear? So just simplify this, simplify these equations, then we will come to know that, x will become equals to 1, x is equals to 1, and y becomes equals to 2, y is equals to 2, and z will become equals to minus 1, is it clear? So like that, if you do calculation or simplification of these three equations, then we will get the values of x, y and z. Now substitute the value of x, y and z in the equation 1, then I will get the relation, So please have an idea here. I will write somewhere here only. Equation 1 implies f is equals to m power 1, v power 2, r power minus 1, which implies f can be written as mv square divided by r. We can take k is equals to 1. K is the proportionality constant, and the value of this proportionality constant is determined to be equal to 1 experimentally. Okay, so this is how we can get the relation between various physical quantities. Okay, these are the applications of dimensional analysis. Okay, now let us move on to the what are the limitations of dimensional analysis. Let us see what are those limitations of this dimensional analysis. What the limitation says, it says that where the dimensional analysis fails, or where we cannot apply the dimensional analysis, in what situations we cannot apply the dimensional analysis. Let us have an idea about the limitations of dimensional analysis. The first one, we have to think that this cannot be used to confirm whether the given equation is a physical equation or not. For example, there is an equation, let us say v by 2 is equals to 3u plus 3 by 2 into at. Okay, so whenever we check this equation, using dimensional analysis, says that this equation is correct. Therefore we can say that, so please think about this. This equation is dimensionally correct. This equation is a dimensionally correct equation. If you want, you can check it. But this equation is not a physical equation. It is not a physical equation. Okay, so like that you have to think here. It is used to check, but it is not used to confirm whether the equation is exact physical equation or not. So what is the exact relation between v, u and at? V equal to u plus at, is it right or not? But this is just an equation, it is not a physical equation. So see here, observe this second one. This can be used to get the relation which is in product form, Okay, you can observe that. We can observe that the previous example. So whenever we go with the dimensional analysis, we can get the relation, which is in the product form or which is in quotient form. Is it clear? F is equals to mv square by r. Okay, such type of relations can be obtained by the dimensional analysis. Later, this cannot be used to get the value of the constants of proportionalities. As I said, see here, constant of proportionality. In this example, we cannot get the value of this k equal to 1 using dimensional analysis, and these values can be obtained only through experiments. Okay, so by not only the constants which are not having the units, but we cannot obtain the values of the constants which are having the units also. For examples, see here, whenever we go with the capital R, that is a gas constant, that is 8.314 joule per mole per Kelvin, or we can say capital G. Capital G is a universal gravitational constant. We can say 6.67 into 10 to the power of minus 11 Newton meter square per kilogram square. So see here, these are all the constants which are having the units. Though these constants are having the units, and the values of these constants cannot be derived or cannot be obtained based on the dimensional analysis. This is one of the limitation. Later we can go with, see here, this cannot be used to get the relation which involve addition or subtraction of the physical quantities. For example, see here, whenever we go with S is equals to ut plus half at square. This is the equation. This is a physical equation which involves the addition of the two terms. And such type of equations cannot be derived using the dimensional analysis. Later, see here, this can be used to get the relation. Which depends only on three fundamental quantities like mass, length and time. So see here, dimensional analysis can be applied to derive the relation between the physical quantities when that quantity involves only three fundamental quantities like mass, length and time. What is the meaning of that? Suppose the physical quantities are having more fundamental quantities, or the physical quantities involving with more fundamental quantities, then we cannot go with the dimensional analysis. It fails to get the relation. We get the relation between the various physical quantities whenever that depends on more than three fundamental quantities except mass, length and time. Okay, so these are all the limitations. These are limitations of dimensional analysis. Okay, I hope you understood these points clearly. If anyone has the doubt, please comment. So that I will explain to you. Now, based on these concepts, let us have an idea to how to solve the numerical problems or MCQs. Okay, so in that, the first one, please observe this, the equation p plus a by v square into v minus b is equal to constant. What is the unit of a? What is this capital V stands for? This is not small v, it is capital V. Okay, van der Waals equation, V represents volume. Okay, and they are asking us to calculate or write the units of A. How can we write the units of A? Using dimensional analysis. So please observe that, and in order to solve such type of question, we have to remember the principle of homogeneity. What the principle of homogeneity says? It says that whenever the quantities having the same dimensions, only such quantities can be added or subtracted. Okay, based on that, see here, by the principle of homogeneity, we can say that, please observe the equation, A divided by V square is added to the term P, where P stands for pressure. Okay, therefore we can say dimensions of this P must be equal to dimensions of A divided by V square. So which implies I can write A as the product of P into V square. What is the P? P stands for pressure. P stands for pressure. Therefore, what is the dimension formula of pressure? M power 1, L power minus 1, T power minus 2. Okay, volume is L power minus 3 whole power 2. Whole power 2. So please do simplification. A becomes equals to our dimensions of A becomes equals to M power 1, L power minus 1 minus 6 will get minus 7 into T power minus 2. Is it clear? So please observe this. M stands for mass and L stands for length and T stands for time. T stands for time. Is it clear? So please please remember that and understand this particular point. Volume is nothing but meter cube. No, therefore we cannot go with L power minus 3. It should be only L to the power of 3. Therefore we can get L to the power of 3 square is 6. 6 minus 1 is 5. M power 1, L power 5 and T power minus 2. But they are asking to write the unit of A in terms of dyne centimeter. It is a CGS unit. Unit. So observe this. How can you write this? You can write unit of A as gram centimeter to the power of 5, and also you can say second to the power 2. So what is this dyne here? Dyne can be written as it is a CGS unit of the force, that is gram centimeter per second square. Gram centimeter per second square is the value of one dyne. So I can rewrite this. So please observe this. Gram centimeter per second square. Gram centimeter per second square into centimeter to the power of 4. So what is this gram centimeter per second square? We can say it is a dyne. Okay. Therefore we can say dyne into centimeter to the power of 4. Hence we can select option B as the right answer. Okay. I hope you got this solution. Is it clear? If anyone has the doubt, please put a comment. So similarly, let us move on to the next question. What they are saying to us: if x is equals to at plus bt square, x is equals to at plus bt square, where x is the distance travelled by the body in kilometers, while t is the time in seconds. Then the unit of B they are asking us to write the unit of B. So how can we write? Same concept, by the principle of homogeneity. We can write the dimensions of x must be equal to dimensions of A into T must be equal to dimensions of bt square, because in a physical equation, a physical relation, what the principle of homogeneity says, all the terms must possess the same dimension. Therefore you please take these two things, these two terms. X is having, okay, I will rewrite x is equals to b into t square, or b is equals to x divided by t square. So therefore what is the dimensions, unit. So b will have the unit of meter divided by second square. X will be in kilometer. No, therefore what is the unit of this? Kilometer per second square. Will represents the unit of b. Hence we can select option C as the right answer. I hope you understood this point, how to apply the principle of homogeneity. Either to get the unit of unknown quantity or to get the dimensions of unknown quantity in a given equation. Okay. Now let us see the next problem, what they are saying to us. what is the unit of Stefan's constant? What is the unit of Stefan's constant? So see here, in order to get the unit of Stefan's constant, first we should know what is the relation. What is the relation? And we have learnt from the chapter or in the chapter thermal properties of thermal properties of matter, especially in the topic heat transfer under the radiation. Under the radiation, we can say that see here, energy radiated by a black body. Energy radiated by a black body. It is given by see here, E is equals to, especially energy per unit area per unit time. Energy per unit area per unit time. Energy per unit area per unit time is equals to sigma into T to the power of 4. T to the power of 4. Therefore, sigma can be written as E. Sigma is equals to E divided by A into small t into capital T power 4. So please observe this. Sigma E will have the unit joule. Okay, A will have the unit meter square. T is having the unit second, and Kelvin to the power of 4. So whenever we do the simplification, we can say that joule per second per meter square per Kelvin power 4. This is the SI unit of Stefan's constant. Hence we can go with option B as a right answer. So from this you have to understand that whether if you want the unit or if you want to get the dimensional formula, first thing we should know the relation. That is nothing but a formula. If you don't know the formula, that is impossible to write the units or a dimensional formula. Okay, please learn those things using the NCERT textbook. So let us move on to the next one. What is SI unit of universal gas constant capital R? Universal gas constant capital R. How can you write the SI unit? So observe this from the gas law. That is ideal gas law. We can write P into V is equals to mu into RT. What is the P here? P represents pressure. V represent volume. Capital T represent temperature, absolute temperature, and mu stands for number of moles. Therefore, R can be written as P into V divided by mu capital T. So P into V is measured in the unit of joule. Mole is a unit used to measure the mu, and Kelvin. Therefore, we can go with what is the SI unit of capital R. Capital R will have the unit. Observe this: joule per mole per Kelvin. Therefore, we can go with the option C as a right answer. No confusion. SI unit. They are asking us to write the SI unit of universal gas constant capital R. Is it clear? Now let us move on to the next question. What they are saying to us. See here, x is equals to 3yz square. Find the dimensions of y. In MKSA. Observe this. MKS capital A stands for current, ampere. Okay, MKSA system. If x and z are the dimensions of capacity and magnetic field respectively. Please observe this. Given, what is the given equation here? Given is x is equals to 3yz square. Therefore, we can write y can be written as x divided by 3z square. Therefore, what is the dimensions of this y here? Dimensions of y is nothing but dimensions of x divided by dimensions of z square. Let it be equation 1. So please write what is x stands for. X stands for dimensions of capacity, that is the capacitance. That is a capacitance. Okay. So what is the dimensional formula? We must know the dimensional formula of the capacitance, otherwise it will be difficult. It will be difficult. So how can we do this? How can we do this? What is the dimensional formula? Dimensional formula for capacitance. So if you want, we can get the the derivation, or you can derive. We can derive. Otherwise, we can write directly. We can write directly. So let us see here. See here. What is the dimensional formula for capacitance? Capacitance. That is x. X will have the dimensions. X will have the dimensions. That is m to the power of minus 1, m to the power of minus 1, and l to the power of minus 2, and t to the power of 4, a square. That is the dimensions of capacitance. Now what is the dimensions of z? Z indicate magnetic field. So dimensions of z can be written as m to the power of 1. Already have derived for magnetic field. T to the power of minus 2 and a to the power of minus 1. This is a dimensional formula for magnetic field intensity. So whenever we do the substitution of this x and z in this equation 1, then we will get the dimensions of y equals to, observe this, m to the power of minus 1, l power minus 2, t to the power of 4, a square divided by square. I am writing directly here, m to the power of 2, t power minus 4, a to the power of minus 2. So whenever we do simplification, then you will get m to the power of minus 3. There are two options, and you will get t to the power of 8. Therefore, we can go with the option D as a right answer. Option D is the right answer. Okay. So like that, we have to learn and we have to remember the dimensional formulas. Otherwise, it will become very difficult. So similarly, let us move on to the next question. What they are saying to us. See here. L, C and R denote the inductance, capacitance and resistance respectively. The dimensional formula of C square into L into R. They are asking us to calculate the dimensions of C square L into R. So see here, such type of problems can be solved in two methods. One, by substituting the dimensions of individual quantity in this given expression and simplifying. Otherwise, we can also do such type of problem by remembering the standard formulas. How to do this? I am going to explain the second method. Observe this. This can be written as, see here, C square into L into R. Whenever we multiply this equation by L and divide it by L, then we will get, see here, C square into L square into R by L. So what is this? L into C into L whole square can be, is proportional to, observe this. We know F is equals to 1 by 2 pi root LC. Is it clear? Therefore, it is proportional to F to the frequency to the power of minus 4. Frequency to the power of minus 4, which is nothing but second to the power of minus 4. What is R by L? R by L stands for, will stand for, we can say that R by L will stand for the time constant, reciprocal of the time constant, that is L by R is said to be time constant. Therefore, we can say it is second to the power of plus 1. So please observe this. Now substitute all the values, in the given equation. Then you will get the exact answer. What is the dimensions of C square L into R? C square L square can be written as T to the power of minus 4 into L by R is T power 1. L by R is T power 1. But we are having R by L. Therefore, we can say that, what can you write here? L, R by L, R by L. Whenever we do simplification here, we will get R by L is T to the power of minus 1. But somewhere I did mistake. Please observe this. I will rewrite this equation for you. F is proportional to root LC, or LC is proportional to 1 by F square. So, or LC whole square will become equals to, or it is proportional to, proportional to. How can we get this here? 1 divided by F to the power of 4, F to the power of 4. So, whenever we do simplification, then you will get the exact answer. Analyze this. What you will get? Frequency. Frequency will have the unit per second. Therefore, we can say that, we can write, observe this, 1 by second to the power of minus 4. When you take the reciprocal, then you will get T to the power of plus 4. So, whenever you do simplification, then you will get T to the power of 3. Therefore, please go through the options here. T to the power of 3. There is only one option, that is option B. Okay. I hope you understood this question clearly. Is it clear? Any confusion? You please go through explanation once again. Then definitely you will get the exact answer. Now let us move on to the next question. What they are saying to us. Please think about this. A force capital F is given by F is equals to AT plus BT square, where T is the time. What are the dimensions of A and B? So I am giving this problem as a homework. Please do this problem. By using the principle of homogeneity. So with that, you will get the answer. Option B. Please check it. Check and comment your answer. Please check and comment your answer. Is it clear? I hope you can easily do this problem. Now let us move on to the next question. What they are saying to us. See here, the position of a particle at time t is given by the relation. X of t. It is not x into t. It is x of time. X of t indicates that position depends on time. It is equal to. Sorry, here there is a typing error. It is equals to V0 by alpha into 1 minus e to the power of minus alpha into t, where V0 is a constant, where V0 is a constant and alpha is greater than 0. The dimensions of V0 and alpha are respectively. So observe this, x of t. It is not x into t, it is just x of t. Position with respect to time. V0 divided by alpha into 1 minus e to the power of minus alpha into t. So here one thing we should be very clear, that exponential, it is a number. So whatever the quantity that exists as a power of e, is a dimensionless. Therefore you can write m power 0, l power 0, t to the power of 0. Therefore alpha can be written as 1 by t, which is nothing but, so please observe this, alpha will have the dimension which is equals to t to the power of minus 1, Understood? Now please think about this. X is equals to, multiply this value, V0 divided by alpha into 1 minus V0 by alpha into e to the power of minus alpha into t. Now we want to get the dimensions of this V0. Therefore, by the principle of homogeneity, by the principle of homogeneity. By the principle of homogeneity, we can equate the dimension of x with the dimensions of v naught by alpha. Therefore, dimensions of v naught becomes equals to the product of x into alpha, x into alpha. So what is the x here? Position. Position in the sense we can go with L to the power of 1 alpha t to the power of minus 1. So what is the correct option we can say here? Please think about this. We can get t to the power of minus 1, t to the power of minus 1 for alpha, L power 1, t power minus 1. Hence we can select option A as the right answer. Option A as the right answer. Okay. I hope you understood this and it is clear. It is clear. So similarly, let us move on to the next question. Let us move on to the next question. How can you answer this question? Please read this question here. The number of particles is given by n is equals to minus capital D into n2 minus n1 divided by x2 minus x1, crossing a unit area perpendicular to x-axis unit time. So what is the meaning of this? See here, n stands for number of particles per unit area, per unit time. We have to read completely about the given quantity. So if you read n as number of particles, then it is wrong. Wrong. So we have to understand what is the meaning of this particular symbol. Therefore, we can say the dimensions of this n can be written as per unit area. That is 1 divided by area is L square, unit time L to the t to the power of 1. So we can write it is L to the power of minus 2 and t to the power of minus 1. Is it clear? So like that we have to understand about the dimensions of this small n. Okay, one minute. They are saying that crossing unit area perpendicular to it here. I hope you understood this, how to write the dimensions of the given quantity. And similarly, what is a small n and small n2? n1 and n2 dimensions. n1 and n2 number of particles per unit volume. See here, number of particles do not have any unit, dimensions, but per unit volume. Therefore, dimensions of this can be written as L to the power of minus 3 per unit volume. Okay. So see here, value of x meant to x1 and x2 will have the dimensions equals to position. So we can write it as L to the power of 1. Now we have to calculate the dimensions of capital D. That is diffusion constant. So please observe this equation here. Small n is equals to minus D into, we can write n1 minus n2 divided by x1 minus x2. Is it clear or not? X2 minus x1. Okay, I will rewrite this. n2 minus n1, they have given it as n2 minus n1 divided by x2 minus x1. Therefore, please observe this. Diffusion constant will have the dimensions of this s and dimension of this x divided by dimensions of n1 or n2, whatever it may be. Just take x1, x2 both represents position only. So you can write directly x. You can write. So observe n d is equals to, what is the dimension formula of n here? L power minus 2 t to the power of minus 1. You can write L to the power of 1 divided by, what is n1? n1, n2 is nothing but L to the power of minus 3. L to the power of minus 3. So dimensions of D becomes equals to, Please do simplification here. L power minus 3, will take to numerator plus 3. You can write L to the power of 2, t to the power of minus 1, t to the power of minus 1. So L to the power of 2, t to the power of minus 1. You will get option D as a right answer. Option D as a right answer. I hope you are understanding and you are following these questions clearly. If any confusion, you can ask. If any confusion, you can ask. Now, similarly, let us move on to the next question. Let us move on to the next question. What they are saying to us. Please have a look about this. The potential energy of a particle varies with the distance x. X is the distance from a fixed origin as u is equals to a into root x divided by x square plus b. X square plus b. So see here, U, what is U stands for? U stands for potential energy, which is nothing but energy having the dimensions m power 1, L power 2, t power minus 2, where A and B are dimensional constant. Then dimensional formula of A into B. They are asking the dimensions of A and B. They are not asking the dimensions of A and B. They are asking the dimensions of AB is. So how can we get it? How can we get it? Please have a look here. I am giving this problem as a homework. So whenever you observe this denominator, then we can say the dimensions of B is equals to dimensions of x square. Then you will get L square. So observe this. We can say that A into root x can be written as U into cross multiply x square plus B. Therefore, A into L to the power of 1 by 2. Is it right? Can be written as U. What is U here? M power 1, L power 2, t power minus 2. What is x square plus B? Since both the quantities are added, dimension formula will remain same, which is nothing but L square. Therefore, please observe this. A can be written as m to the power of 1, L power 4, t power minus 2 divided by t power 1 by 2. Then calculate the dimensions of this A. Finally, multiply the dimensions of A and dimensions of B, and please take this as a homework. And reply your answer. How much you are getting? Okay. I hope you can easily do this problem here. You can easily do this problem without any hesitation. And you should get the answer. Nearly. That is L to the power of option B. So please think about this. A into B. If you multiply A into B, then you will get m power 1, L to the power of 11 by 2, t power minus 2. Please, I hope you can easily do this problem. Okay. Let us move on to the next question. I think you can do this here. Dimensions of P. They are asking only dimensions of P. So please take this problem as a homework. And remember my words. What? We have to read completely about the given symbol. Here B stands for magnetic induction, L stands for length, and M stands for mass. Homework. Please do this homework. So therefore, you should get the answer. Approximately. That is not approximately. Exactly. That is option B. Instead of capital A, ampere, they are using capital I in this problem. Instead of capital A, they are using capital I to represent current. That's it. So don't get confused. I hope you can do this problem. Any confusion, please put a comment, then I will explain to you. Now let us move on to the next question. What they are saying to us. In CGS system, read the question carefully. In CGS system, the magnitude of the force is 100 dynes. Magnitude of the force is given as 100 dynes. In another system, where the fundamental physical quantities are kilogram, meter and minute and minute. The magnitude of the force is, So see here, one system is given as CGS and other system is given as a kilogram, meter and minute as the fundamental quantities. So how can we get, or how can we convert, or how can we get the value of this force in the second unit? So please observe this. We can say that N1 is equals to 100. N2 we have to calculate. What is this U1? We can say it is a dyne. And U2 we have to calculate, that is a new units. What is the force? What is the dimensional formula for the force here? That is m to the power of 1, L to the power of 1, T power minus 2. Now as we discussed, whenever the quantity remains constant, then we can write N1 U1 is equals to N2 U2. Therefore N2 is equals to N1 into, please observe this, M1 by M2 whole power 1. You can say L1 by L2 whole to the power of 1 and T1 by T2 whole to the power of minus 2. So please observe this. N2 is equals to, what is N1 here? N1 can be written as given as 100. Dyne is nothing but gram centimeter per second square. So please look at the board. M1, that is gram, divided by M2. What is M2 here? Kilogram. It is a kilogram to the power of 1. What is L1? L1 is centimeter. What is L2? L2 is a meter. To the power of 1. What is the T1? T1 is second and T2 is a minute. Whole to the power of minus 2. So please do simplification. N2 becomes equals to 100 into grams. Grams can be 10 to the power of minus 3 kilogram. Otherwise, please convert the kilogram itself to gram. 10 to the power plus 3 gram to the power of 1. Centimeter divided by 100 centimeter to the power of 1. And here second divided by minute is nothing but 60 seconds to the power of minus 2. So whenever we do simplification, then you will get the value of N2. After cancellation, then definitely you will get the value of N2 is equals to 3.6. Please check the answer and comment the thing. So 3.6. Hence we can select option C as a right answer. Okay. I hope you can easily solve such type of questions here. Now similarly, let us move on to the next question. I hope you are understanding these questions clearly. So please go through it once again. If you have any confusion, please message. Let us move on to the next one. What they are saying to us. To determine the Young's modulus of a wire, the formula y is equals to F by A into L by delta L. So L is the length, capital A is the area of cross section, delta L change in length of the wire when stretched with a force capital F. The conversion factor to change it from CGS to MKS. I think you can do this problem here. Y is equals to F by A into L divided by delta L. Please use the dimensional analysis and solve by yourself. Take this as a homework. Then you should get the answer. As so please observe this. You should get 0.1. I hope you can do this problem. So see here. If you want, I can give you the hint. So, Young's modulus. SI unit is Newton per meter square. And CGS unit is dyne per centimeter square. So please check it, apply this, then definitely you will get the answer. Please think about this. N1 into U1 is equals to N2 into U2. Let us assume N1 is equals to N2. Find out N2. Then you should get the value of N2 is equals to 0.1. I hope you can easily solve and you can easily answer this question. Is it clear? Now similarly, let us move on to the next question. What they are saying to us. Please think about this. Conversion of 1 megawatt power of on a new system having basic units of mass, length and time. Basic unit mass, length and time as 10 kilogram, 1 decimeter and 1 minute respectively. See here, power. What is the unit here? Power. What is the dimensional formula for the power? We can say it is nothing but energy per second. Therefore you can write m to the power of 1, L to the power of 2, T to the power of minus 3. So please observe this. M1 is nothing but kilogram. We can make a graph kilogram. L1 is a meter and T1 is equals to second. And similarly M2, second unit, second system, M2 can be as 10 kg, which is okay, let it be 10 kg. And what is this L2? You have to use it as 1 decimeter, which is nothing but 10 to the power of minus 1 meter. Decimeter is nothing but 10 to the power of minus 1 meter. Okay. And similarly, let us see what is the time. T2 is nothing but 1 minute, which is equals to 60 seconds. So use the relation. N1 U1 is equals to N2 U2. What is N1 here? N1 is nothing but 10 to the power of 6. N1 is equals to 10 to the power of 6. And do substitution and simplify this value. Then definitely you will get the answer. As N2 will become equals to 2.16 into 10 to the power of 12 units. Okay, please take this, do this problem as a homework. Hence you will get the answer as option A. 2.16 into 10 to the power of 12 units. I hope you can do this problem clearly. Is it clear? Will you solve this problem? Please put a message. Now similarly, let us move on to the next question. How to solve this problem? Let us have an idea. See here, 1 gram centimeter per second is equal to x Newton second. Then the number x is equivalent to 2. So how can we solve in simple way? Observe this. 1 gram centimeter per second is equals to x into Newton second. So 1 gram centimeter per second is equals to x into, what is Newton here? Newton can be written as kg meter per second into second. Is it clear? So please observe this, kg meter per second square. Whenever we do simplification, look at the board here. Gram centimeter per second is equals to x into 1000 gram. Meter means 100 centimeter into per second. Please do simplification. Per second, centimeter, gram will get cancelled. Therefore 1 is equals to x into 10 to the power of 3 into 10 to the power of 2. Therefore x becomes equals to 10 to the power of minus 5, which is nothing but option D. D as a right answer. Okay, I hope you understood this question clearly. Now similarly, let us move on to the next question. In this way also we can convert the unit of one quantity from one system to another system directly. Is it clear? Now let us move on to the next question. What they are saying to us. From the dimensional consideration, which of the following equation is correct? From the dimensional consideration. That means we have to go with the dimensional analysis. So how can we do this? Please. So in order to solve this type of questions or such type of questions, okay, there is only one option. We have to go with the optional verification technique. Okay. So let us take one by one. By option verification technique, let us have the first option, that is t is equals to 2 pi into root of r cube divided by g into capital M. So what is the dimensions of LHS? Nothing but t. That is t to the power of 1. So RHS, whenever we consider the RHS, please observe this, 2 pi is a constant, so no need to worry about the dimensional formula. We can say root of r cube divided by g into capital M. So r cube divided by gm can be written as gr square whole to the power of 1 by 2. So please check this. R is nothing but, what is r here? R can be written as r square and r q will get cancelled. R by g whole to the power of 1 by 2. So please observe this, L to the power of 1, here L to the power of 1 t power minus 2 whole to the power of 1 by 2. Therefore dimensions of RHS will be equal to, please look at the board here, t square whole to the power of 1 by 2. Then you will get the dimensions of capital T. Okay. Therefore we can say that LHS term is equal to RHS term dimensionally. Therefore we can say the option A as a right answer. Therefore no need to verify the other options. So see here, in such type of problems or in this type problems, almost all first option will be the correct answer. Okay. So therefore no need of calculating the remaining options. Is it clear? I hope you understood this question clearly. Now similarly, let us move on to the next question. What is this? With the usual notations, the following equation ST is equals to U plus half A into 2t minus 1 is only numerically correct, only dimensionally correct, both numerically and dimensionally correct, neither numerically nor dimensionally correct. Here what is this ST? ST indicate that it is the distance travelled in nth second. Therefore dimensional formula of this ST will be equals to L to the power of 1 t to the power of minus 1. Now what is the dimensional formula for U? U is equals to L power 1 t power minus 1, and dimensional formula of A into 2t minus 1. Please think about this. L to the power of 1 t power minus 2 into t to the power of 1. Whenever we do simplification, then we L power 1 t power minus 1. So from this we can say that the given equation is correct both dimensionally as well as numerically. Okay. So what is the value here? What is the answer here? Both numerically and dimensionally correct equation. What is this? This is the equation represents the distance travelled by the particle in nth second. I hope you understood this question clearly. Now let us move on to the next question. What they are saying to us. Please do this problem here. If velocity v, acceleration capital A, and force capital F are chosen as the fundamental quantities, then the dimensional formula of angular momentum in terms of A, V and F would be? First of all, let us understand what is the dimensional formula for angular momentum. Angular momentum. L. L is equals to m into v into r. So whenever we do this, so see here, kg meter per second into meter. So dimensional formula for L becomes equals to m to the power of 1, L to the power of 2, t power minus 1, t power minus 1. That is the angular momentum. Is it clear? So you can do this problem in two methods, in two techniques. One is optional verification technique. Otherwise, second one is using principle of homogeneity. I will give this problem as a homework. See here, observe this. We can say L is proportional to, we can say f to the power of x, v to the power of y, a to the power of z. So observe this, m to the power of 1, L power 2, t power minus 1 is equals to 1 into what is f? F is nothing but a force. Is it clear? Therefore, we can write it as m power 1, L power 1, t power minus 2 to the power of x. V is nothing but L power 1, t power minus 1 to the power of y. And a is nothing but acceleration. Acceleration is L power 1, t power minus 2 whole to the power of z. I think you can do this problem here. Please take this problem as a homework and give me the answer. Please take this problem as a homework. So, equate the dimensions of LHS and RHS. Find the value of x, y and z. Find the value of x, y and z. Then you will get the answer. Okay. I hope we can do this problem. And by solving you will get x is equals to 1, y will become equals to 3 and z will become equals to minus 2. Z is equals to minus 2. Hence we can go with option B as a right answer. I hope you understood this one clearly. So if you have any doubt, you please comment so that I will explain to you. So similarly, let us move on to the next question. How to answer this question? Please read this. If velocity v, force capital F and energy E are taken as the fundamental units, then the dimensional formula for mass. They are asking us to write the dimensional formula for the mass or the relation for the mass in terms of velocity, force and energy. So usually same as usually, okay, we will proceed that m is directly proportional to, we can say v to the power of x and f to the power of y, e to the power of z. So what is the mass? Dimensional formula of mass is m to the power of 1 and we can write is equals to 1 into velocity L to the power of 1, t power minus 1 whole to the power of x. Force we can write m to the power of 1, L power 1, t power minus 2 whole to the power of y. And E is the energy. Energy is nothing but m to the power of 1, L power 2, t power minus 2 whole to the power of z. So just equate the powers. M power 1, L power 0, t power 0 must be equals to m to the power of y plus z, L to the power of x plus y plus 2z and t to the power of minus x minus 2y, okay, minus 2z. Is it clear? So just equate the dimensions, then we will get y plus z is equals to 1, x plus y plus 2z is equals to 0, minus x minus 2y minus 2z is also equal to 0. So just use this and simplify, then definitely you will get the answer. So please think about this. Let us call this equation. Now this equation can be written as, we can write plus x plus y plus 2z is equal to 0. Whenever we add these two equations, x will get cancelled. Therefore, we can get finally here minus y is equal to 0, or y becomes equal to 0. Y is equal to 0. Substitute the value of y in this equation 1. Therefore, we will get y plus z is equals to 1 implies z becomes equals to 1. Now substitute the value of x. What can you say about the x value here? Substitute the value of x, then definitely you will get the answer. So please think about this. What will be the answer you are getting? So substitute the value of x, y and z in this equation 2. Let us say here x plus y is equal to 0 plus 2 into z in nothing but 1 is equal to 0. Therefore, we will get x value is equals to minus 2. X is equals to minus 2. Therefore, substitute the value of this in this equation, then you will get the answer. So, therefore, whenever we go with, we can get option A as a right answer. Option A is a right answer. So, like this, we have to solve such type of numerical or MCQs. And this will take some time. But if you practice as many problems as possible by taking any one of the reference books, then it will become very easy. And you can easily answer within a minute, by practicing, only by practicing. Understood? Now similarly, let us move on to the next concept. That is significant figures. So what is significant figures? We can say that the sum of certain and uncertain digits, the sum of certain and uncertain digits, okay, are called significant figures. So how can we identify the significant figures? For that we are having certain rules. And with that rules, and we can easily identify the number of significant figures. So please think about this. First rule, what are the rules to identify or to write the significant figures in a given value or in a given number? First one, observe this. All non-zero digits are significant. For example, if I write 287, then the number of significant figures will be equals to 3. Or non-zero digits. 2 is a non-zero digit, 8 is a non-zero, 7 is also non-zero digit. And whenever the second one, we can say that 589. Here also we can say otherwise 5896. The number of significant figures in this number is equals to 4. Okay, that is the first rule we have to keep in our mind. That is, all non-zero digits are significant. And second rule, say here, a 0 becomes significant figure if it lies or if it appears between the two non-zero digits. For example, see here, whenever we consider 200,367, since observe this, the two zeros are lying between the two non-zero digits 2 and 3. Therefore, significant figures will become equals to 6. Number of significant figures will become equal to 6. And similarly, whenever we go with this number, observe this 6 point, okay, 00897, then the number of significant figures will also be equal to 6, because the zeros which are lying in between the two non-zero digits are always significant. And let us move on to the next one. Trailing zeros are never significant. That means the zeros which are occurring at the end of a number. Okay, I will explain by giving an example here. If I say 2700, we can say from this we have to eliminate these two trailing zeros, and these two zeros cannot be taken as a significant. Therefore, how many significant figures are there in this? We can say it is equals to only 2. Is it clear? Now similarly, let us move on to the next example here. If I take 899 0, then here in this case there will be only 3 significant figures, and the trailing 0 cannot be considered as a significant figure, a significant digit. And let us move on to the next one. Trailing zeros after a decimal point are significant. Trailing zeros after a decimal point. For example, see here, if I take 689.00, that there are zeros after a decimal point, then those zeros are taken as a significant. Therefore, we can say significant figures is equals to 5. And let us see another example. So let us move on to this. So 100.00808. So observe this value. How many significant figures are there in this number? Observe this. So many zeros are there. 1, 2, 3, 4, 5. And these zeros are lying in between 2 non-zero digits. So they are significant. Along with this trailing 0 that is existing after a decimal point. Therefore, we can say that the total number of significant figures is equal to 7. Is it clear? So we have to remember these rules. Now let us move on to the next one. Zeros after a decimal point and before a non-zero digit are not significant. That too we can say clearly for a number less than 1. Whenever we consider a value or whenever we consider a number which is less than 1, okay, no worry, I will explain through an example. I will take a number, see here, for example 0.896. How many significant figures are there? Observe this. The 0 before a decimal point are not significant. So in this case there are only 3 significant figures. And second example, see here 0.00545. Then how many significant figures are there here? So see here, the 0 after a decimal point before a non-zero digits are considered as non-significant. Therefore, we can say only 3 significant figures. So like this, we have to analyze the significant figures with these rules. When a number is less than 1. So let us see next one in exponential notation. For example, see here, if I take a number 3.78 into 10 to the power of 20. Otherwise, second example, I can take it as 8.989 into 10 to the power of minus 19. So how many significant figures are there in this case? First example, so see here, the numerical portion gives the number of significant figures. So in this case there are 3 significant figures, and in this case there are 4 significant figures. So like this, we have to understand and we have to realize how to find the significant figures by learning and remembering the rules of significant figures. Okay. Now similarly, whenever we go with arithmetic operations, because in our practical life or in our real life we may come across the values which we have to add or which we have to subtract or which we have to multiply with each other. In such conditions or in such arithmetic operations, how to identify the number of significant figures? So please have a look here. Remember this rule. So that we can avoid the multiplication of the numbers to identify the number of significant figures. In order to avoid the multiplication, you have to remember this rule. See here, in multiplication or division, either we can multiply the number or divide the two numbers. The final result should retain as many significant figures are there in the original number with the least significant figures. Okay, I will explain the meaning of this. So let us consider two numbers. Let us consider two numbers. 142.06 into 0.23. Is it clear? So in this first number, significant figures is equals to 5. Significant figures is equals to 5. In the second number, significant figures is equals to 2. Is equal to 2. Whenever we do multiplication, then I will get this value 32.6738. If you want, you can calculate using the calculator. No worries. So in this, how many significant figures should exist, or how to express the final result? For that, we have to read the given statement once again. Once again, we have to read. So observe this. Whenever we consider two given numbers, we have to consider the number which is having the least significant figures. In the first number, we are having the 5 significant figures. In the second number, we are having only 2 significant figures. Then how to express the final result? That is our question. So see here, observe this. First of all, 32.6738. We have to express this final result in only 2 significant figures. How? By rounding off. I will explain what is the rounding off in the next upcoming session. See here. So see here, 32 point, we can say that 32.7, otherwise we can approximate this as 33. This is the final result. So similarly, observe this. Whenever we multiply this, there are only 3 significant figures in the given thing. So final answer should be equal to 66.8. So like that, we have to follow the rule. In order to write the significant figures, identify significant figures, or express the result when multiplying or division. Similarly, whenever we go with addition or subtraction, the final result should retain as many decimal places. We should retain as many decimal places as are there in the number with least decimal places. Okay. So see here, in order to understand the statement, we have to go with an example. First example, see here. Whenever we add 33.3 plus 3.11 plus 0.313. So in this, there are 3 significant figures or decimal places. We have to concentrate on decimal places. In this, there is only 1 decimal place. Is it clear? And in this, there are 2 decimal places. And in this, there are 3 decimal places, we can say. Is it clear? Therefore, final answer should contain the number of decimal places which is equal to least in the given number. In the given number, the least decimal place is equals to 1. Therefore, the final result should be equals to 36.7. Okay. And similarly, we can go with this. In this, the number of decimal places is equals to 4, and in this, the number of decimal places is equals to 3. In this, the number of decimal places is equals to 2. Therefore, the least decimal place is equals to 2. Therefore, we have to express the final answer as 3.47. Okay. So like that, we have to apply the rules. To find the number of significant figures. Okay. I hope you understood these rules. I hope you understood these rules. Now let us move on to the next concept. That is rounding off. So please observe this. In order to round off the value, we have to follow certain rules. So see here. First one, I will explain through examples. First example. So please see here. Examples. Whenever we take 25.689. Now I want to round off this value. Up to 2 decimal places. If you want to round off this up to 2 decimal places, I want to release or I want to leave this third digit. And see here, the digit which is to be left, the digit which is to be left, is if I write, if the digit which is to be left is greater than 5, then its preceding digit, digit should be raised by 1. Therefore we can write this, observe this, 25.689 can be written as 25.69. Okay, and similarly second example, so see here, if I go with 26.684, now I want to leave the third digit after a decimal point, that is equal to 4. So since it is less than 5, less than 5, we can write the final answer as, if it is less than 5, then we have to drop the digit as it is. It is equals to, how can I write this? 26.68. And similarly observe this third example. If the digit to be dropped is equal to 5, then observe this, then we have to think about the preceding digit value, if it is even or odd. So please think about this example. I will give an example here. 1. Take this example, 6.845, and second example is 6.875. Now I want to drop this third decimal digit. So observe this. In this number, the preceding value is even. When the preceding value is even, then leave that digit as it is, or drop the digit as it is. Therefore we can write the answer as 6.84. If the preceding digit is odd, then we have to increase the preceding value by 1. Therefore we can write it is 6.88. So these are all the rules which we have to remember, while rounding of the digit, and to how many digits we have to round off, that is also we should take care. Okay, now let us move on to the next few example problems to analyze this questions. So see here, first one, the number of significant figures in 0.007 meter square. According to the rule, 0.007 will have the significant figures equals to 1. Is it right or not? Because see here, the zeros before a decimal point and after a decimal point and before a non-zero digit are insignificant. Therefore we can go with the answer A. That is option 1. The answer 1, option A. Okay, so similarly let us move on to the next question. Each side of a cube is measured to be, that is A is equals to 5.402 centimeter. The total surface area and the volume of the cube in appropriate significant figures are. So see here, first one, how to calculate the total surface area. So please think about this. Total surface area of the cube is 6a square. So observe this. area involves multiplication of the sides, So in multiplication we have to concentrate on number of significant figures. Since in the calculation of area we will take only one value, that is equal to side value, so we have to take the significant figures is equals to 4. Significant figures is equals to 4. Is it right? So whenever we do multiplication, the result, no need to calculate each and every value. So see here, 6 into 5.402 whole square, definitely you will get the answer as 175.08 something. You will get it. I am not calculating the value exactly because I am keeping the rule. I am keeping the rule in our or in my mind. So see here, how many significant figures are there in the given value? It is equals to only one value is there, and in that value how many significant figures are there? It is equals to 4. So final result should also contain only 4 significant figures. Therefore, what will be the answer here? See here, option A, option B, both are having the 4 significant figures. And similarly, let us calculate the second one. Second one is volume of the cube. It is nothing but a cube. Again, volume depends only on one value, that is a. A is having the 4 significant figures. Therefore, this should also contain only, what is it? Final answer, centimeter cube. Options, please check the option here. 157.6 centimeter cube. It is equals to 175.1 centimeter square. So this is the final answer. Hence we can select option B as a right answer. Is it clear? So like that we have to think and we have to analyze these questions. Now let us move on to the next one. Please do this problem here. Take this as a homework. Observe this and observe this, then definitely you will get the answer. Will you do this problem? I hope you can easily do this, because in multiplication, okay, you will get some value. So how many significant figures are there in this case? There are 4 significant figures in both the cases. Therefore, please do simplification, then definitely you will get the answer. As how much it is. Whenever we do simplification, then you should get each number is having 4 significant figures. But among the given options, we are not having the value which is having the 4 significant figures. Therefore, we can go with only 3 significant figures after rounding off. So please do calculation, then you will get option B as a right answer. Whenever there is no 4 significant figures option, then we have to go with 3 significant figures. By rounding off. Hence we can get option B as a right answer. Now similarly, let us move on to the next one. I hope you can do this. How many significant figures are there here? 11.118 into 10 to the power of 6. Significant figures 1, 2, 3, 4, 5. Significant figures is equals to 5. Hence we can select option C as a right answer. Is it clear? Now similarly, let us move on to the next concept. That is the last concept of this chapter. That is errors of measurements. Errors of measurements. So how can we define this error here? Most probably this concept has been deleted in our NCERT textbook, but you must require an idea. To answer the few models or few questions from other chapters or in other chapters. So what is that idea? We must require and we must learn so that we can answer the questions. We can answer the questions in upcoming chapters. So in order to get that, we must learn this error concept briefly. Okay. So see here, what is an error? Error is defined as the uncertainty in the measurement, the uncertainty in the measurement of a physical quantity, So what is this uncertainty? So for example, see here, I will take this pen, and I will measure the length of this pen. I will measure the length of this pen. With different objects or different instruments. Suppose if I measure with the help of a meter or ordinary scale, then definitely I will get some value. And if I measure the length of this pen with the help of a screw gauge, then I will get some other value. And if I measure this length with the help of a tape, then I may get a little bit different value. That means based on the instrument we are using, to measure, okay, the value of this length is changing. So because of that, there will be some uncertainty or there will be some mistake in the measurement, and such mistakes are referred as errors. So see here, errors are broadly classified. I will explain it briefly here. Errors are broadly classified into two types. One is called as systematic errors, and the other one is called as So see here, first one, systematic errors and random errors. Okay, and the other one is, we can say that first one, that is a mean absolute error. We can define this as a mean absolute error. Please, I will rewrite this. Mean absolute error. Okay, first of all, discuss about absolute error, and second one, mean absolute error, and third one, we can go with relative error or fractional error. We can also call this relative error also fractional error, and also we can go with percentage error. So how these errors are classified? One is based on the reason. How the errors are getting for us? To us while measuring a physical quantities. Based on the reason, we can have systematic errors and random errors. Okay, and second one, that is based on magnitude of the errors. We can have absolute error, mean absolute error, relative error, and percentage error. Okay, so see here, systematic errors will occur either in increasing direction or in decreasing direction. Okay, and random errors will occur because of temperature variations, or because of fluctuations of the voltage. Whatever the error we get, that is called as a random error. Okay, and see here, what is the reason for getting systematic error? It is nothing but it is because of the instrument we have chosen may be wrong to measure a quantity. And second reasoning, say here, if you follow the wrong procedure, by following the wrong procedure or by following the wrong method, we may get the systematic error. Third one, because of the individual bias or because of the individual error, we may get the systematic errors. Random errors, because of the temperatures variation or because of the voltage fluctuations, we will get random errors. This is how we can give a reason to get the error or for the occurrence of the error. So, based on magnitude, how much is the error? What is the magnitude of the error? Based on that, we can go with absolute, mean absolute, relative error and percentage error. So, most probably we must require this knowledge especially to solve the numerical questions. So, see here, what is the absolute error? Before going to see the absolute error, let us say A1, A2, A3, so on, AN are measured values of a quantity, of a physical quantity in n number of trials, For example, I will take this pen, I will measure this length, length of this pen for 10 times, or 20 times or 50 times. So like that, in each and every trial and each and every measurement, I will get one value. So like that, A1 is the measurement in first trial, A2 is the measurement in the second trial, A3 is the measurement in the third trial, so on. AN is the measurement in nth trial. So first of all, before going to calculate the absolute error or mean absolute error, we have to understand about what is the mean value or absolute value. So see here, A mean is equals to A1. A mean can be written as A1 plus A2 plus so on AN divided by n. So see here, if I add all the values, all the measurements and divide it by number of trials, then whatever the value we get, we call that value as mean value or as true value or absolute value, okay, or perfect value. Okay, so later see here, what is the error? What is the absolute error? First one, absolute error. What is the meaning of absolute error? So see here, absolute error can be calculated for each and every trial. So please think about this. There is a difference between the value in the first trial minus mean value, or anyway we take only magnitude. So that will give you what is the error in the first trial. Similarly, what is the error in the second trial, which is nothing but A2 difference AM. Is it clear? And like this, whenever we go with the error in the nth trial, AN minus A mean. So like this, we have to calculate the absolute error. And second one, we can go with the mean absolute error. So please think about this. Mean absolute error is nothing but is the average of all the errors will give you the mean absolute error. If we add all the individual errors or all the absolute errors calculated in each and every trial and divided by n number of trials, then you will get what is the mean absolute error. And similarly, what is the next one? Third one, that is a relative error. So please don't forget, and we have to learn this relative error. Relative error is nothing but the ratio of mean absolute error to its mean value. That is a relative error. Now what is the fourth one? That is a percentage error. So please observe this percentage error. Percentage error is nothing but the relative error expressed in percentage. Relative error expressed in percentage is called as percentage error. Is called as percentage error. Now observe this. When the two quantities are errors in combination. Now I am going to give the formula for calculating the errors in the combination. So see here, when the two quantities are added, or subtracted, so see here, like for example, if we add the two quantities A and B, then we will get Z. So what will be the error? Observe this. R Z is equals to A minus B also. Either we can add the two quantities or we can subtract the two quantities. We will get the result. By adding, we will get the sum. By subtracting, we will get the result as difference. Either in sum or difference, the result delta Z is always equals to delta A plus delta B. And you have to concentrate here. Errors are always be added. Errors can never be subtracted. Errors should not be subtracted. Errors should always be added. So observe this. I am repeating the statement. The absolute error in the sum or in the difference. Absolute error in the sum or in the difference is equal to the sum of absolute errors in the individual quantities. Okay. And similarly, whenever we go with, so see here, when the two quantities are multiplied, or divided, then we will not get the absolute error, then we will get the relative error in the product, or quotient. Relative error in the product or quotient is equal to the sum of relative errors, in individual quantities. These are very important for us. So see here, for example, if I take the two quantities A and B and if I divide it, we will get the product. We will get a product. Or if we multiply the two quantities, I will get the result that is called as if I divide, we will get quotient. If I multiply, then we will get product. So see here, in this we will not get the absolute errors. We can calculate or we can get only relative errors, either division or multiplication. So observe this. The relative error in the product or in the quotient is always equal to the sum of the relative errors in the individual quantities. Okay. And similarly, the next rule, observe this. When a quantity is raised to certain power, then we will get the error or the relative error in the result is equals to the power times the relative error of individual quantity. I will write this with the help of an example, then you will get a clear picture. For example, see here, if there is a quantity which can be written a power p, b to the power of q divided by c to the power of r, d to the power of s, then what is the relative error in the result? Delta z by z can be written as p into delta a by a plus q into delta b by b plus r into delta c by c plus s into delta d by d. So like this, we have to remember the formula in the calculation of the errors. Okay, these are the very important concepts or the important formulas which we have to learn from this particular topic, the concept errors. Now let us apply these formulas in solving the numerical problems. Let us see the first question. Observe this, what they are saying to us. A physical parameter A can be determined by using or by measuring the parameters B, C, D, E using the relation. Please observe this. A is equals to B to the power of alpha, C to the power of beta divided by D to the power of gamma into E to the power of delta. Okay, observe this. The maximum errors in the measurement of B, C, D and E are percentage they have given B1, C1, D1 and E1. So please, what they have given to us, please look at the board. It's a very important concept. Though the concept is not there in the syllabus, we have to learn so that we have to solve the problems in some other chapters. So see here, given that delta B by B is equals in percentage is B1 and delta C by C in percentage is equal to C1% and delta D by D in percentage is equals to how much here? D1% and delta E by E in percentage is equals to E1%. Okay. So how can we get this? Please observe this. The A is a physical quantity which is expressed in the exponential form. Therefore, we know that delta A by A can be written as alpha into delta B by B plus beta into delta C by C, okay, plus gamma into delta D by D. As I said, errors are always be added. You should not subtract the errors, either in subtraction or in division. Okay, so see here, we should not subtract delta E by E. So whenever we substitute the given values, then you will get the option D as a right answer. Okay, I hope you understood this problem clearly. Is it clear? I hope you are following each and every step. Just substitute. If you want, I can write delta A by A in percentage is equals to alpha into what is delta B by, that is a B1 plus beta into C1 plus gamma into D1 plus we can say delta into E1 percentage, even in a percentage. Hence we can select option D as a right answer. Now let us move on to the next question. What they are saying to us. Please read this question carefully. The pressure on a square plate is measured by measuring the force on the plate and the length of the sides of the plate. If the maximum error in the measurement of force and length are respectively 4% and 2%. See here, measurement in the force delta F by F is equals to 4% and delta L by L is equals to, see here, it is a 2%. Then they are asking what is the maximum error in the measurement of pressure. So see here, since it is given a square plate, we know that, look at the board and note down by concentrating. So see here, we know that pressure is equals to force by area. Area can be written as L square. Therefore see here, pressure depends on force, pressure depends on L to the power 2. Therefore error in the pressure, delta P by P can be written as delta F by F plus 2 into delta L by L. So delta P by P in percentage is equals to delta F by F 4% plus 2 into 2%. So whenever we multiply this value and add it, then you will get the answer as 8%. Hence we can select option D as a right answer. Option D is the right answer. Is it clear? So like that we have to think and we have to analyze each and every question. Now similarly, let us move on to the next question. What they are saying to us. Observe this. The resistance capital R is equals to V by I. R is equals to V by I. Where V is equals to 100 plus or minus 5 volt and I is equals to 10 plus or minus 0.2 volt. So whenever we observe this type of representation, see here, V is equals to 100 plus or minus 5. Is it clear? So from this we have to think what is 100. 100 stands for mean voltage, okay, and 5 stands for error in the measurement of the voltage. Similarly, I is equals to 10 plus or minus 0.2. In this, what is the 10? 10 stands for mean value 10 ampere and delta IM is equals to 0.2 ampere. Is it clear? Therefore, what is the percentage error? Percentage error in the measurement of resistance. See here, from this we can say that delta R by R can be written as delta V by V plus delta I by I. What is V? V stands for mean value and I stands for mean value of the currents. So just substitute the value of this here. Therefore, delta R by R is equals to delta V is 100 divided by 5 plus delta I is 0.2 divided by 10. So whenever we do the simplification, delta R by R is equals to 100 by 5 is 20 plus here you will get 0.02. Is it clear? So any confusion you please ask. I hope you understood this point. So please think about this. Then you will get the answer as nearly 20.02. Is it clear? So please think about this. Sorry, I made a mistake here. I have considered the values in opposite manner. Delta V is 5 divided by 100 plus 0.2 divided by 10. So you can say it is 0.05 plus 0.02, which is nothing but 0.07. But they are asking in terms of percentage. Therefore, we can say that delta R by R in percentage is nothing but 0.07 into 100%. So whenever we do multiplication, then you will get the final answer as 7%. Hence we can select option B as a right answer. Option B is right answer. I hope it is clear to you and you are understanding each and every step. Now similarly, let us move on to this and take this problem as a homework. Please take this problem as a homework because it is a simple question which involves only calculation. If you want, I can give you the hint. So see here, A1 is equals to 2.63 seconds, A2 is equals to 2.56 seconds, A3 is equals to 2.42 seconds, and A4 is equals to 2.71 seconds, and A5 is equals to 2.80 seconds, and they are asking what is the average absolute error, delta AM. We have studied the delta A1 plus delta A2 plus delta A3, okay, like that, A3 plus so on, plus delta A5 divided by 5. Just add all the values and calculate. Then definitely, before that, first calculate what is the mean value. Mean value can be obtained by using the formula A1 plus A2 plus A3 plus A4 plus A5 divided by 5. Just add all the values, divide by 5. Then you will get what is the A mean, that is a true value. After getting the true value, then calculate the error in each and every trial. Use the formula I have given to you, then definitely will get it. So finally you will get the answer as 0.11 second. 0.11 second. I hope you can do this problem easily. This is one of the previous NCERT problems. So let's see the next one, what they are saying to us. I think you can do this problem happily. I am giving this problem also as a homework. So see here, H is equals to I square into R into T, and they have given, observe this, delta I by I in percentage is equals to 3%, delta R by R in percentage is equals to 4%, delta T by T in percentage is equals to 6%. Therefore, we can say that, observe this, delta H by H in percentage is equals to 2 into delta I by I plus delta R by R plus delta T by T. So just substitute all the values. Okay, I will only do it. 2 into 3 plus 4 plus 6. So 6 plus 4 plus 6, which is nothing but 16%. You will get 16%. Hence we can select option B as a right answer. Okay. So like that, we have to think and we have to analyze each and every question. Now similarly, okay, these are all the questions. Which are given in the previous years NEET papers. So why I have solved these models. So please go through these questions and go through these concepts and take one reference material and please solve all the problems from that reference material. Then you will get a nice confidence. Okay. So I hope you understood these concepts and the numerical problems, and if you face any difficulty in understanding or if you are not able to understand, please put a comment. So that I can explain to you. Once again. Okay. So with this, I am going to end my video and we'll meet you in the next chapter. Until then, please keep preparing. Don't waste your time. Okay. Thank you very much. Bye bye.